it's referring to it like the warm-up, but all right, so it says up here, solve the equation 2 times the absolute value of x minus 5 minus 4 equals 2 by graphing. So we want to know, when are these two equations equal to each other? So to do that by graphing, I would graph f of x as the left-hand side of the equation, and then graph g of x as the right-hand side of the equation, and see where they intersect. That's one way to do this. So just kind of playing around with, I mean, we didn't do this specifically yesterday, but we did that was a weird error. I don't know how you got that. Okay, so we did graph these types of functions, absolute value functions. So when you have one of these, this form here, I could recognize that I have a vertex at x minus, this is the h value, 5, plus this value, plus -4 is the k. So 5, -4 is going to be the vertex. And then this 2 in front tells me that it is stretched. Okay, so if I pick a couple values here for x, maybe I'll pick 0 for x and see what happens. I can type in the function here. I wonder if it'll let me copy and paste this. Try it. Oh my gosh, that works. That's amazing. Well, there you go. You can copy and paste it instead of trying to type it. But replace the x with 0. And then as soon as you click out, it's going to solve it for you. I already have it copied, so I'm just going to Control V paste it. And pick another value for x. Let's try 10. These are just values that I'm randomly picking because they show up on this axis and they're on equal sides to the vertex, equal distances from the vertex. So I have a couple ordered pairs, 0, 6, 0, 6, and 10, 6, 10, 6. And that should make sense because when you graph the absolute value function, it is symmetrical. There's a line of symmetry right through the vertex, just like with a quadratic parabola. Same kind of idea with the absolute value V-shaped function. Okay, and then to graph g of x equals 2, so select x values to plug into it. Well, this is kind of weird because if I pick any value of 2, like 0, and then I try to plug it into this function, which is just 2. Oh, I didn't let me copy it. You know, nothing happens because there's no x in here. So it doesn't matter what number I put here. I could put 10. I'm still going to get 2. I could put negative 1.67, and I'm still going to get 2. Okay. It's just everywhere it's 2. So it's a vertical line going through 2. So if you check the sketch, you would see that, yes, here is the absolute value function. Okay, and then this is the graph of g of x equals 2. It's just a, I know I just said vertical like 10 seconds ago, and I now just realized I said that. It's horizontal, not vertical. Vertical is up and down. Horizontal is side to side. I apologize. This is a horizontal line. Okay, so the reason these are both graphed here is to see where the solutions are, and it's where they intersect. Okay, the x values of where they intersect is 2 and 8. So down here, if you type in 2 and 8 and check it, you would get the correct solution. All right, so we didn't do exactly this yesterday, but we did do similar stuff to at least this first part here, where we're graphing functions that are absolute value functions. So that's the review part. This other stuff is a little bit not review. Anyhow, as soon as you are ready, click next. Okay, so add in the values or some values that you want to use and click next, and then we'll move forward. Once I have at least half of the class, I'll move forward, trying to stay guys' pace. Our summary. I'm checking that the people that are not moving forward, you are still in the meet. So if you're looking at the meet, go back to student. All right, so I have a majority of us that are now on 3, which means I'm going to extend this to slide 4, and I'm going to show you guys slide 3 and then do 4 with you. So 3, there's nothing for you to do. This is just our steps. We today are going to be solving absolute value equations, and these are our steps. So first thing, you isolate the absolute value, which means you get it on one side of the equal sign by itself. And then the second step is to split that into 2 equations, one where it's equal to the positive version of what's on the other side of the equal sign, and one where it's equal to the negative version of what's on the other side of the equal sign. And then you just check your work. So there's a question here. It says, in an equation, the values inside the absolute value lines are done first right. Yes, they are. That is correct. Okay, and so we're going to see that here. We're going to actually work out this equation, solving it algebraically, which means we're going to show our work in this area here. You can try to draw on this area. You can try to type. I really haven't figured out how the equation tool is any different than the text tool. So if you do figure that out, let me know. I'm just going to use the text tool, and then when it comes to putting in these absolute value signs, I'm just going to use the line tool to draw those in. So it'll work that way. So we're going to work it out here, put our solutions here, check that they're correct, and then graph them on a number line. All right, let me zoom in. So you can highlight and copy, and then click in here, and I think paste. Oh, yeah, that didn't work very well. Nope, can't. So that does some type of weird coding thing. So you have to actually just type this in. So we have x minus 3 in absolute value. I'm going to add in after I type it, plus 2 equals 5. Maybe the equation does something about the spacing. Let me check if that is what makes it. Oh, it does. It does the spacing for you. X minus 3 plus 2 equals 5. Okay, so that's how it's different. This, you have to add in all the spacing. The equation tool will put in the spacing for you. But I don't know how to get the absolute value sign, so I'm just going to add it in like that. Okay, so you guys can do that. Use the equation typing tool, type out x minus 3 plus 2 equals 5, and then use the line tool to draw 2 lines around to represent the absolute value. So those steps that we have on slide 3, isolate the absolute value, that's what we want to do first. And we do that by using inverse operations. Okay, so I'm going to use the pencil tool now, though, and just go ahead and show that I'm subtracting 2 from each side. Because I want to get these constant terms together, and since I'm trying to get the absolute value by itself, I need to get this 2 out of here, and then I can rewrite my equation as x minus 3 equals 5 minus 2 is 3. and then draw in my absolute value bars. So that was step one, isolate the absolute value. We did that. Step two, which says back here on this screen 3, is we're going to set this absolute value equal to the positive and negative version of what's on the other side of the equal sign. And we drop the bars when we do that. Set what is inside the absolute value to both the positive and negative 3, to both positive and negative 3. All right, so one of our equations is, and we drop those absolute value bars, x minus 3 equals 3. And then the other equation we're going to get is x minus 3 equals negative 3. So we're setting it to both versions. So we take this, and it's either equal to positive 3 or negative 3. So I'm adding more steps here than they originally gave us, but that's okay. Step 3. Solve both equations. Okay, so we're going to again use inverse operations to do this. Here's a minus 3 and a positive 3. The x is over here, so I want to add 3 and add 3, which then leaves me with just x equals 6. Okay. Yeah, negative 3 plus 3, that's 0, but 3 plus 3 is 6, so. And then we're going to come over here and solve this equation also. So let's add 3. Notice we're doing the same thing because we have the same thing on the left-hand side. It's just the right-hand side that's different. And we're going to add 3. So negative 3 plus 3 is 0. And that leaves me with x equals negative 3 plus 3 is 0. So those are my two solutions. We have x equals 6 and x equals 0. So now you can come to this check your solution part and type in your two answers of 6 and 0, and then see, it'll tell you if you're right or wrong. Green check is good. Red X is bad. And then graph the solutions on the number line. So where are 6 and 0 on this number line? Well, there's already a point here at 0. We're going to put another one here at 6. And then those are the solutions, and you can check it. Yep, that's it. Okay, so I am going to open up slide 5, and when you're done copying slide 4, click the next button, and then when I have at least half of us, I'll know that most of you are ready to move forward. So together as a class, we are going to go up to slide 7 together. So we're going to do 3 more slides, 5, 6, and 7, and then you're going to be doing slides 8 and 9 on your own. And remember, this is an assignment that's going to go into Aries. And if I ever do go too fast, which I will go too fast for some of you, I'm sure, that's why I record it. So you can go back, you can watch the video, you can pause the video, go right to where you need, you can get what you missed, and get caught up that way. Okay, so I have at least half of us that have made it to slide 5. I'm going to go to slide 5. We can always come back. Slide 5, don't have to do anything to it. It's just the definition of absolute value. Absolute value, and I told you guys this yesterday, it is distance from 0. You can think of it that way. When you're asked to find the absolute value, you're being asked to find how far away from 0 is that number. Absolute value, just like distance, is always, well, it's not always positive, but it's always non-negative. I didn't write this, so that kind of bothers me. It can be 0. 0 is okay, and 0 is not positive, 0 is not negative. So absolute value is always non-negative. So 0 is an acceptable answer, or any positive number. But generally, when you think it's always positive, for the most part, that's correct. Okay, so we're going to move up to slide 6. And we're going to look at solving an absolute value equation where there are fewer than 2 solutions. So the last one we solved, there were 2 solutions for x. That's not always the case. Sometimes there could be 1 solution. Sometimes there can be no solution. So what we do is when you're solving these, once you've done that first step of isolating the absolute value, you kind of evaluate what you have in terms of knowing that absolute value has to be positive. And if your absolute value is not equal to something that's positive, that's a problem. And then you would just write that there's no solution. So we're going to start with this one here. I'm going to, again, just try to copy and paste it. I don't think it's going to work, but maybe it'll work for me. Oh, it worked. I think maybe because I used the this button. So try that. Try to just highlight this. You can then Control C to copy it, and then click this and click in here, and then Control V to paste it. Again, my first step is the same. We're trying to isolate that absolute value. So to do that, I made it larger. Learning how this Desmos thing works a little bit more every day. All right, so I'm trying to get this absolute value of x plus 1 by itself. It's being multiplied by -5, and we have +2 happening. I have to get rid of this +2 and this multiplied by -5. As far as what thing you get rid of first, this is easier to get rid of first, okay? So in order to get rid of this +2, we just subtract 2. And you know, that's what you should do first, -2. And if I subtract 2 on the left side of the equal sign, I should subtract 2 on the right-hand side of the equal sign. That cancels out. And now what I'm left with, let's see if this works. 12 minus 2 is 10. I already had it copied to the clipboard. I just pasted it and kind of edited it a little bit. And that made it really easy to show my work. Okay, now that I only have 1 term on each side of the equation, it's easier to get rid of that factor of -5. -5 and the absolute value of x plus 1 are being multiplied together. So if I'm trying to undo that, well, I could divide both sides now by the same factor. Divide both sides by the same factor of -5 and -5. I think I like Desmos better for working out equations because it just seems easier than Deck. Doesn't let you copy and paste and do this kind of stuff as well. All right, so -5 divided by -5, that's 1. Those cancel out. And I'm just left with the absolute value of x plus 1. And that's equal to 10 divided by -5, which is a positive and a negative. When you multiply or divide, gives you back a negative. 10 divided by 5 is 2, so -2. Okay, there's something wrong though, right? Absolute value is equal to negative something. That can't happen, okay? Absolute value cannot be negative. So when that happens, you stop doing your work and you write no solution. And you're done. Absolute value can be 0. Absolute value can be positive. Absolute value cannot be negative. Okay, so again, I'm going to let you get caught up right here. You can check your solution. And when you're ready, click the next button, and then we'll move on to the next screen or slide, whatever you want to call it. Okay, so I have 9 of you ready to move on. 5 of you are still working on slide 6. Angel and Hugo, you guys are on 4 and 5 right now. All right. So I'm going to go ahead and go to slide 7. And this says absolute value equations with fewer than 2 solutions. Example 4, isolate the absolute value expression in the equation to determine if the equation can be solved. If so, finish the solution. If not, type no solution. So that's what we just did on the last one. It turned out that we couldn't solve it because we got something that didn't make any sense. Absolute value can't be negative. So let's see what happens with this one. Again, copy, highlight it, Control C, click on the equation. Oh, it's called the math tool. Click on the math tool, click in the box, the largest box, and then Control V, and look at that. It just does that for you. That's wonderful. Okay, so this is what we are going to be, and I'm going to make this larger. That's what we are trying to solve. Steps are the same. We want to get the absolute value by itself. And if you look at all the things that's happening to the absolute value, here's our equal sign. So on the left-hand side, absolute value is being multiplied by 3/5. Absolute value also has -3 being subtracted. So I have to get rid of both of these things. And getting rid of this -3 is a lot easier to do first. So that's what we'll do first. And the way you get rid of that -3 is by doing the opposite. You would then just add 3 plus 3, because -3 plus 3 is 0, and that makes it go away. But if I add 3 to the left-hand side of an equation, I have to add 3 to the right-hand side of an equation. And this is going to simplify my equation. And I already have it saved to the clipboard, so I should be able to just control paste it and then edit it to match what I need. So we take out that. Then over here, -3 plus 3. -3 and 3 are opposites. They add to 0. So now I want to deal with this factor of 3/5. Now on the last problem, we had a factor here to get rid of, so I just divided by it. Okay, essentially that's what we're doing. If I divide 3/5 by 3/5, if you think back to how you divide fractions, that's where you keep the first fraction the same, you change it to a multiplication problem, and you flip the second fraction. So 3/5 divided by 3/5 is the same as 3/5 times 5/3. Okay, and the reason that this helps the situation is that these 5's cancel to 1, those 3's cancel to 1, and then there's nothing left on the left-hand side. But I also have to multiply by 5/3 over here. Absolute value of 2x minus 4 is left. I'm just going to come up here and just copy that part. And that's equal to 0 times 5/3. 0 times anything is 0. Okay. So I've gotten to the point where the absolute value is isolated. 2x minus 4 is by itself. It equals 0. That's okay. Absolute value could be 0. That's fine. If I drop these bars and then write two equations equal to the positive version of 0 and the negative version of 0, that doesn't make a whole lot of sense, because there's no such thing as positive and negative 0. There's only 0. So there's only one equation that comes from this, and it's this equation right here. So what we're left with is 2x minus 4 equals 0. Okay. If you wanted to write it 2 times just to be consistent with the method and the steps, you could. But, you know, solving both of these equations is going to give you the same answer because they're the same equation. So it's not really necessary to write it 2 times, but, you know, just following that method of dropping the bars and taking the positive version and the negative version. This is a special case because it's 0 and there is no positive and negative version. So we're just going to solve one of these because we're going to get the same answer if we do it twice. Add 4. Add 4. Gives me 2x equals 4. Because negative 4 plus 4 is 0, that's gone. Okay, and to solve this, we would just divide both sides by the factor being multiplied by x, which is 2. 2 divided by 2 is 1. So then I'm just left with the solution of x equals 2. And you can check it. Check your solution. Good. Okay, so I'm going to turn off all the pacing, not being restricted on what slide you're on. The next 2 slides, slide 8, you're going to solve this absolute value equation algebraically. You're going to show your work here. Then you would put your solutions here that you get and graph them on this number line like we did earlier. And for 9, you're going to solve this one here. Write your solutions here. If there is no solution, you would write no solution. On this last one we just did, it said if there's only one solution, type the answer in the first box, which is what we did. There was just one solution for this. Because if I solve both these equations, I get x equals 2 twice. So you don't have to write it 2 times when it's the same answer.